Hello everyone. Welcome to ME416 and in this project we are going to design a heat exchanger and I am Guangchao Song.
I'm Jiang. Heat exchanger is widely used in space heating, refrigerating, air conditioning, power stations, and chemical plants. The theory is that one of the fluids that is either heated or cooled flows into the tubes, and the other fluid runs over the tubes, such that it can either provide the heat or absorb the heat that required. Theoretically contain tube inlet or outlet, shell inlet or outlet, and baffles. The design goals for the heat exchanger will assist in cooling the computers of the High-Performance Computer Center of MSU. It will use drinking water that is sent out from different buildings on campus to reduce the cooling cost. The water flows out of a relatively large reservoir located near the engineering building. The heat exchanger will continuously dissipate 1 megawatts of thermal energy that generated by the computers of MSU's HPC. It should be easier to clean, and the pressure drop should be minimized. Last of all, the heat exchanger will be designed to meet the requirement and will be analyzed in the following steps. The following is the basic design constraints for our heat exchanger. First of all, it has to be a shell and tube heat exchanger. Second, the temperature of water flows into the inlet is 57 Fahrenheit, and the temperature of the water that flows outside should not increase more than 3 Fahrenheit degree. The volume flow rate of the heat exchanger is approximately 10 to the 6 gallons per day. The current piping has a 14-inch inlet diameter. The length of the heat exchanger should not exceed 25 feet long, and the temperature of the coming fluid should not exceed 120 Fahrenheit. This page is showing the basic calculation for the analyzed part of the designing this heat exchanger. We calculate the volume flow rate of this system.
Our group chose BEM type heat exchanger. The hot stream is propylene glycol, which is on the shell side. The temperature of incoming hot stream is 90 Fahrenheit degree and the outcoming is 85 Fahrenheit degree. The cold stream is designed to use water and the inlet temperature is 57 Fahrenheit degree. The outlet temperature is 60 Fahrenheit degree. By using the formula of Q equals m dot times Cp times delta T, our team comes up with the results of 0.305 megawatt for heat exchanger. There are 4 cases that are generated by the program, but our team chose case 3. Although the prices for the first 2 are lower than the third one, the pressure drops of shell and tube are relatively higher than the third design. The third case costs moderate money, but the pressure drop for hot and cold stream side is relatively low, such that it may reduce potential failure as the heat exchanger works. The last case can be overlooked since the cost is the most expensive and the pressure drop is higher than the other 3. This slide shows the schematic drawing of the design heat exchanger. The blue table demonstrates the parameter, and on the right side, it explains the cross-section of the arrangement of the tube. There are 173 tubes with the 30 triangular tube pattern. The heat exchanger can dissipate nearly 0.3 megawatt. However, the computers of MSU HPC generate continuously about 1 megawatt. Therefore, the volumetric flow cannot accommodate this situation. There are 4 cases generated by ASPN program. However, only one of the cases works, since the solution depends on pressure drop and the cost of the exchanger. There are many suppliers for the heat exchangers in the world, but our group chose 3. The first one is GFD2, and the second one is Trenter, and the third company is Preheat.